Good evening, Mr. Shan.
Good evening, sir. Good evening, ma'am.
Hey, Tashana. Hey, Ricky, how are you doing? Okay, Ricky and Tashana, projecting a question.
Yes, sir.
I'm projecting a question here. I want you to try to give an attempt on average rate of change.
Okay.
Just look at it, see what is it that you can comment, and I'll come back and do it again.
Sir Sean, the background is a bit loud.
Yeah, man, no problem. I'll fix it. Cool.
So do this question.
Sir, do you have the answer for this one?
Ricky,
Hmm.
sir, I think with the noise in the background, I could hardly hear what you were saying, but I think you said we're supposed to work this one out.
Oh, my work it out, want to know if it's right.
All right, so what I have,
Wait,
Is-
you work it out already?
well, sir gave it to us, but the answer is already on the paper that you sent us, the limits paper. So I decided to work it up myself, and it's still the same answer.
What's the answer
Five.
again?
5.06 minus 3.91 divided by 1999 minus 1987. So it would be 1.15 divided by 12, which gives you 0.10 USD.
Divided by 12. Why you divided by 12?
Because
From
all right,
in 1987 to
well, no,
yeah.
no, take away 1987 from 1999. What's the figure you get?
So you do it?
If you, all right, take away. Let me take the calculator because I had to do it a while ago. Sorry. The year 1999 minus 1987. So that's 1999
1999 minus
1987.
12.
Right. The answer is 12. So the average, like if we look at it, 5.06 is like right on a 1999, right? Technically in the center, call it that.
Hmm.
Yeah. So if you divide the year and the price, you subtract the smallest amount from the middle figure, same way with the year. So the middle year
Hmm.
from the lowest year. You divide those two, you end up with the answer. That's what I gather from this.
Okay. Maybe kind of different still. More know the answer.
The answer is 0.10.
Really? Is that on the limits paper too?
Hold on, sorry. It says concert tickets increased by 0.10 USD each year from 1987 to 1999.
0.10, so that's 10 cents.
Uh-huh.
Let me go get this limit. The recent limit paper
The most recent one that he had sent to us. This is on
yeah.
it. Because I was going to ask him once I scroll down, I was going to ask, sir, how is it him give us something we already have the answer to? But I'm looking at the principle. Where the
Okay.
solution is, we have the year right in the center, you have 6 years going up. Was it 6, 7 years going up, and right in the center is 1999, and the figure is 5.06. So you subtract 1987 from 1999, you come up with 12 years. And for the price, you subtract $3.91 from $5.06, and you get $1.15.
The highest.
You divide the $1.15 by the 12 years, and you get the figure 10 cents. So it increases by 10 cents.
Right.
And it's from that year, from 1987 to 1999. So if you wanted to calculate from the year 2000, from 2009,
You just use the same principle.
Right.
Yeah.
All right.
Right.
I absolutely love that level of reasoning and that level of collaboration, and this is what it involves. Somebody understands it, takes it to the class, and it is what I'm looking for. So I hear you. I was eavesdropping. I was muted. I was eavesdropping, and I love it. I actually love it. No, I'm serious. I really and truly love it. It sounds good. And I hear you talk about your 10 cents. So I know the others are late in coming, but guys, the truth of the matter is that
just briefly again, Tashala, 1987 minus.
No, 1999 minus 1987. Is that in the center right there? That's because you're calculating from 1987 to 1999.
And then the highest
will increase, yeah.
Then is 506 minus.
All right, you want to try calculating from 2009 using the same principle as the way you come up with?
I'm gonna write this down.
All right.
So you minus the 506 from the 3.
No. You subtract the 391, 3.91 from the 5.06, and that will give you $1.15.
Yeah, me reach the $1.15. Me to get that.
What are we doing?
And then you divide the $1.15.
Sorry, average rate of change, Janelle. ARC.
So you divide the $1.15 by 12 now, isn't it?
All right. So she is correct. So So what it is that you do is when we have $5.06 minus the 391 to give you 1.15, and then you're gonna have the 1999 minus 1987 to give you 12. So you're gonna have that 10 cents that you spoke about. Now, that's the average rate of change. So let us go to the question. Let us go to the question.
Okay, come say I was going. I wasn't doing the dates.
Oh yeah, man, you have to. Those are the only two bits of information you're giving us, so you have to go through those. Look at what it is saying. It is saying that the average price for a ticket to a concert for selected years in US dollars is shown below. So 1987, you have the ticket price at $391. 1991 is at $421. 1995 is at $435. So you recognize that every year or every period, the ticket price is going up. 1999, it's 506. 2003, 603. 2007, 688. And in 2009, it went up to $7.50. So ours is now the task to find the average rate of change, find the average rate of change of the ticket price with respect to time. Now, one may ask, and somehow, Ricky, I was hoping that you would have asked the question, so why we put the 506 minus 391 on top and put the 1999 minus 1987 at the bottom? Why we never put the 1987, the 1999 minus the 1987 up on top?
That's a good question.
I thought you were going to answer the question. This is why I was listening.
In the back of my mind, sir, we want to know the average rate of change of the cost of the money over the years. So if we're going to find that out, we have to divide. We have to divide the cost, find out the cost, and then the year divided by the year to see how much it changed over that period of time.
And you are correct. Look at what I highlighted in green, and there's a reason I highlighted in green. It says we need to find the average rate of change of the ticket price with respect to time. So ticket price comes first,
and time after,
and then the time comes after. Right? So it says ticket price, then it says with respect to time. So whichever one comes first, they're on top, and whichever one comes last, they're at the bottom. You see what I say? Yes. So the question, how it is that the word, I can give you the same question and ask you to find time with respect to ticket price. But in this particular case, we want ticket price with respect to time over the period 1987 to 1999. And that's why you know what it is that you're looking at. You know, so them give from 2009 to 1987 or 1987 to 2009.
Yeah, they could have done
exactly
it. They could have done it all the way up to 2009, but they wanted that little timestamp between 1987 to 1999.
Absolutely. So now, so this is how it becomes. This is how it becomes. How it becomes. What do you call it now? Sorry. All right. Sorry. One of my aunts calling me. Decided to stop to send a message that I'm in a class. So what I'm saying to you is that, okay. All right. So I don't know why the tax office comes to mind, but you know, periodically they have an increase in different things like seatbelt fine and road traffic silting and driver's license silting and property tax silting and all of those things.
Yeah.
Right? So we can put the years down and the different increases. And then now we can calculate the average rate of change of something, say driver's license increase, with respect to time. And we can have an idea as to what happens. We can also use it, as I was saying in class, I think I was saying it in class, we could also use it for Burger King. When was the last time I had an increase? What was the increase? So the double whopper moved from this amount of money to this amount of money at this particular time. And we can calculate the average rate of change of the increase in price of the double whopper at Burger King, right? We can look at several different things using the average rate of change. Sir, how are we going to use the average rate of change? You know what it is that you're calculating? It says ticket price with respect to time. So look at what happens here. So ticket price, $5.06 minus 391, because since I'm saying ticket price with respect to time, ticket price is going to be in the numerator, time going to be in the denominator. That's how you read it. All right. Now, how do we interpret it?
Sir?
Where double come from?
Oh, okay.
Right. So the interpretation is concert tickets increased by 1 cent, by 10 cents, by 10 US cents each year from 1987 to 1999. That's the interpretation. But sir, we only have 1987. We don't know what happened in 88. We don't know what happened in 89. We don't know what happened in 90. We don't care about that.
We just want an average. When you think about average,
very good. It's just the average you look on, right? Because remember, you know, the ticket prices here would have increased in 1987. Chances are there are no increases in 88, you know, and 89 and 90. But times get harder, and them said, look, we have to do an increase in 91. You see what I said? So this thing, every 4 years, them do, well, not quite. 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 99. Yeah, so it is periodic that they do the increase. But when you're doing the average rate of change, you can say, well, you know, with the average rate of change, it works out to be every year, this ticket price business go up by 10 cents from 1987 to 1999. And that's how you do the stuff. Courts does it. You move into, as a brand manager for, tell you what, a Jamaica, or in a manufacturing industry, say for example, Lasco, and Lasco has their increase in price. You can say, okay, our prices would increase from this to that over this period of time. Final example, and I got the shock of my life today. I almost choked on my own saliva when I heard it, that the US dollar gone to $155 to one.
Ooh, okay then.
Ah, my Lord, 155, you know, guys, and don't call me old, but I remember when I was in high school and I had friends who lives abroad. You know, you have a pen pal who lives abroad. And those were the days when people used to write and send money in a letter, in an envelope. And you know, fortunately they not teeth it out. And over the summer, we never have WhatsApp. Matter of fact, cell phone wasn't in existence at the time. And the only method of communication, and not many people had landlines at the time, right? So the only form of communication is writing a letter. So you write a letter, and sometimes you write one letter and you anticipate when they're going to respond, and you send another letter, because to send a letter from Jamaica, them times there, it takes a couple of days in order for it to get to where it's going in the US for persons to respond and send it back. So over the summer holidays, June, July, August, you may end up getting like 2 letters. And I remember in one of those letters, I got $5. And I remember saying to myself, forgive me, Lord. I remember saying to myself, I will not spend this $5. I'm going to let it stay until the US dollar reach, the Jamaican dollar to the US thing reach about $1,000. So we can do it, we can calculate and we can get enough money. Because those were cheap days. I'm talking about cheap days. I mean, you could use $100 and go to the supermarket and come up with 2 big bags of food, right? So I'm saying that, and the dollar was like $3.50 to one Jamaica, to one US dollar. So when I see it under $155, no, I'm saying to myself, what is going to happen?
But sir, look at the pound. The pound is 205.
Shut up.
Yes.
Are you serious with me?
Yes, 205. 205 Jamaican to £1.
205?
Yes.
Oh my
Good evening,
goodness.
sir.
Good evening, good evening, good evening. What is going to happen to us?
It soon reach 500.
What is really going to happen to us? What is really going to happen to us? So it is unfortunate that the exchange rate is where it is. But what's the point though? What's the point? The point is we can calculate the average rate of change of this US dollar over a period of time. And trust me, on a 10 cents it's going to work out to be enough money. Because as I said, I can remember, and others can tell you the days when it was either 1 to 1 or a couple cents to 1. But what I can remember, what my memory takes me back to, was $3.50 Jamaican dollars to 1 US dollar. I know Ricky is saying $200 and much dollar for £1. It's rough. It's rough. So it
Very
means
much so, sir.
goods and services. Funny enough, on the weekend, I was driving to the supermarket and I passed a particular gas station and I saw $201 and like 96 cents for a liter of gas. And I sat in the car and I explained, and I said, say what? And I remember nothing like distant past either. This was like the early 2000s. I remember in the early 2000s, I used to pay like $1,200 to fill my car. I mean, I'm talking about any pure tank. My car used to hold 54 liters of gas because anytime I go to the gas station, I always fill up. And it holds 54 liters of gas. And let me just calculate it while I tell you. And the 54 liters of gas, I used to pay $1,200, 1200 for 54 liters of gas. So that means it was like about $22 something per liter. And then the time that people are complaining that the gas price too high. You understand? People are complaining them times that the gas price too high. And now it is $200 and something. So think about it. Call it $202 times 54. That's why I'm paying so much money.
Wow.
That's why I spend so much money the other day. This is like $10,000 something.
Pardon me. Persons normally utilize the year and the time to differentiate. But persons need to remember that at that time, the rate was different prior to now. So you can utilize that to differentiate because the economic is different then than now. So person is going to say, yes, it was expensive at that time, but person are going to still say that because the different economic changes. As they talk about macroecon, they will talk about the equilibrium and all of these things. So you have to take that into consideration when you do your differentiation and all of that, right?
Absolutely. So when you do your price differentiation, this is where the math comes in. So that's the point. So you're actually supporting the point that I'm making. That no, when we're calculating the average rate of change, we can see how the cost of living would have gone from one period to the next. So that's exactly what it is that we're looking at when we're looking at the average rate of change, So yes, I understand that back then people used to cry that things were expensive, yeah. But the truth of the matter is, it was compared to now, one would say that it was cheap. Funny enough, I love old people, and there's one that I go and visit, and she said, I bought this house for $50,000. I was like, wow, $50,000. $50,000 right about now is not even the price of a window for a house. So that's the point that you are saying, Jay, and that's the point that I'm also supporting. Yes, but we can look at the average rate of change over the period of time, that at this particular time, this is what, and this is how the Mandan economics, would use to say it was at this percent compared to this here percent. And one can look and to say, why is it that the dollar would have devalued so greatly? And if you look at it, I mean, math, econ, math, very related. Why is it that the price would have gone the way it has gone? Anybody remember buying a tin of milk years ago when you punch a hole in the tin of milk and you can't even pour the tin of milk because it thick?
Yes, sir.
You have to blow through one side for the milk come out?
Yes, sir.
Yeah, man, right about now, you punch a hole in the milk and the milk will spray out for you because
Just
it's more liquefied. Yeah, but guess what? So the same thing with already is the same thing that we're talking about now. That the price has gone up. Things just move up to then. Shoes, I think I was saying to you that I pull a bag of cheese strips. And I said, yeah, I'm going to devour this. And I could count how many cheese squares in other something. I could count how many cheese squares. By the time I said, it's done. I was like, my goodness, and the price is going up. The price is up. So yeah. So this is how we calculate the average rate of change. Yes, Fears, go ahead.
Sir, the containers are getting smaller and the contents are less and the price go up for it. So yeah, that's what's happening.
Yeah. It is what it is. It is what it is. And one can say that the things that they used to sell before would have been a better quality than what it is that they are selling now.
True,
because
sir.
what they are selling now is for you to mash up so that they can come back and buy again. So you would once buy a pair of jeans that can last if you have 10 years. But now you buy the denim that you wash it 2 times, you use a little washing brush on it, or you put it in the washing machine and it starts freeze out.
It done,
right?
sir. Done.
It done. It wash out because they're not, everything just cutting back. Everything just cutting back. But yeah, so this is how we calculate our average rate of change. So it's a good tool, good business tool for you to be able to look to see why, and it may not be you that is doing the stuff, It could be you are a higgler and you normally buy and sell. And you buy and sell a particular set of something. So you may say, boy, you sell children's dresses and sell children's dresses. And when you sell the dresses, this is what you have been doing for years. And roughly you pay, them could come and buy a dress for $1,000. And then in 1999, them come and the dress gone to $1,200. And by 2003, it gone to $2,500. And by 2021, you pay $10,000. You can actually calculate the average rate of change as to how much they would have put on this item over a period of time. And you can see the changes that would have taken place. Chances are the dress that you buy in 2021 compared to the dress that you'd have bought in 2000.
Because of inflation, sir.
Yeah, it don't last long because by the time you wash it, it shrinks and you can't wear again. You understand? So this is just a practical example of how it is that they do the stuff. All right. Let me just pause right here. I have 10 of you, and I'm seeing some students who who are on that are guilty of this, and I just need to make this announcement. I know one student who is on sent me a message, but I think so far some of you are putting me to the test about completing your pieces on Edithasoft. There are too many of you out of the 12 of you now in class that are yet to start your Edithasoft piece. And I'm going to start closing them out. I looked at it the other day. I know one student sent me a message and explained a difficulty. But I looked at it and I said to myself, I think I'm too nice a guy. And I really have to get tough so that you guys can recognize the importance of hard work. Students, please don't tell me that, sir, is a whole lot of work I have to do and so forth. I understand. I am marking papers from last semester, still marking. But I had to break from the marking to write your exam paper to send off to CCCJ. I had to write your mid-semester exam to send off to editor. And I'm not teaching one course in the summer. All right? Plus, as a matter of fact, let me see if it's still going on. Plus,
Sir, when is your mid-semester exam?
I don't have a clue yet. I will tell you.
Okay.
I will tell you. Right. Plus, there are meetings. All right, like one that I'm in now still on my cell phone that I'm still part of. So it is rough for you students. Don't think that I'm here not having anything to do, and just being cruel to say, do the work. But some of you are going to get zeros and you're going to say that I am evil. But there's a God above that will know that I have been talking to you about completing your assessments. There are some students who are working and working very hard, but there are some of you that are pussyfooting around, completing my work.
Sir, the background, your background is louder than you right now.
No, man, don't worry about it, man. It's a conference that I'm in.
I know, but you're saying something and I'm trying to hear everything you're saying and I'm just getting it in bits and pieces. Sorry.
Yeah, all right. You can hear me now?
Yes, sir.
All right. So, all right. So I'm saying to you, I'm closing them out. I'm closing them out because the work must be done.
Sir, good evening.
Yes, ma'am.
How are you, sir?
I am trying to be good.
All right, sir. Please just give us a little bit more chance.
How much more time am I supposed to give you? Tell me.
All right, sir. Give us still. If Monday come out, we don't finish there, so you can close them out Sunday night.
Okay, so Sunday night I can close them out.
Yes, sir. Sunday night after midnight.
Sir, when you say close down, which section, sir? I'm just curious at this point.
This is week 4. This is week 4. So where we should have been, we get 3 assessments a week. At the end of this, we're supposed to be at pass number 12.
Pass number 12? Sir? Jesus.
Oh, sir, you're just giving an heart attack. Me pass.
Sir, number 12.
You have 3 pieces per week. You have a homework, you have a practice quiz, and you have a quiz.
All right, I'm going to try to reach past 12.
But sir, question, if you only do 1 practice, you all right?
Yeah, you must tell me, you do the practice. If you feel comfortable with it, that's fine. But the point I'm making though is
You're not
that
getting a great feet now.
the point I'm making is, if you, I mean, I could name and shame, you know, because I could share my screen and show you what I'm talking about. There are way too many students in the class who are yet to log on. As a matter of fact, let me tell you one of the things that shocked me today. When I looked at the dates on your last login. Some students have not logged into Editasoft in excess of 2 weeks.
Oh.
In excess of 2 weeks. When I saw the 1st of the 7th, I was like, but we never start summer school on the 1st. And I looked at it as like, oh my goodness. From the 1st of the 7th was the last time some students logged on. The 1st of the 7th. Which would have been, we had a class the Thursday the 1st. And that would have been the last time some of you logged on. But guess what? So when I close them out, none of you can say Mr. Shand is evil. None of you can say that. The semester is short, and I'm going to tell you what is going to happen. Already, I think we get pushed. No, hold on. Already, we get pushed back for, I think, an extra week or 2. I don't remember what you said in the meeting. Could be an extra week or 2. So already I'm looking at your exams running into September. Come September, I'm going to have registration, for new students. And we have the time to mark and to wait on anybody to do the work. So I'm saying to you again, I'm asking you nicely, kindly, go through and finish your work. That's the last thing I'm going to see on it. The next thing I'll see on it is when it is that, matter of fact, I want to tell you, I'll just close them out. All right, so what I'm going to do, I'm going to go ahead so that in the event that I forget, the system will do it automatically. I'm going to put some dates on it. I'm going to put the dates automatically to close out midnight on Sunday.
Sir.
All the way up to 12, sir?
Yeah,
Not the old 12, not the old 12, sir. But some of them were long overdue, right, sir?
Yeah.
Yeah.
Sir, you're talking about unit 1 to be closed off this Sunday?
Unit
Or you're
1 and
talking about
2.
1 and 2.
I work out all the 3. You see, I wanted to understand 3 before attempting it because I know I fail. So I'm going to just go right at it straight ahead. From I understand this section, it shouldn't be so difficult. It's the one that you were working out in the last class that I'm having an issue with, sir.
You're not the problem enough because I see you have completed working. I'm talking about those students who have not even answered one piece of assessment. I see your stuff and I see you have completed some. Anyhow,
sir.
shall we continue? No, yes, last comment and then I'm moving on. Yes, Jay.
Okay, sir.
Sir, one more, please.
Remember my private email, personal email still on it. You get any answer on that?
Yeah, man. I soon sort out that because Kareem, something don't even. If you talk about it now, Kareem, there, Lord Jesus, Kareem, something don't even. I keep forgetting to send off Kareem stuff for them to sort out. No, we can't sort that out. Anyhow.
And mine too, sir. It's still in my private
Yeah,
email.
man, no problem. I soon sort that out. All right, let's continue. Hold on, please.
Sir, I know you said you're not going to put the time when it expires, but can you do that, please?
What is that? What is it, Jay?
It's Shawnee, sir.
Oh, sorry, Shawnee.
You said you're not putting the time when they will be closed out. They will just automatically close out. But can you just do the put the expiration date, please?
Yeah, that's what I said. I'm going to put the expiration date so that it does it automatically.
Oh, so we will see if unit 1 or 2 or 4, whatever,
absolutely,
will be closed. Okay, cool.
All right, let's continue. All right, so that ends the section on limits, and I'm now going to be starting for differentiation. All right, so hold on, let me just change stuff. All right. So we're moving on to differentiation. We're moving on to differentiation. And I'm going to ask for your undivided for this. It is not difficult, but it requires some important stuff. All right.
Sir,
Listen. Are you hearing me?
the limit. Let me make this bigger. The limit approaches H approaches 0.
Mm-hmm. Hold on. I'm gonna. All right. So here goes my question. My question says to you to differentiate 2x squared minus 5x plus 3. To differentiate 2x squared minus 5x plus 3. Now, this is differentiation from first principles. First principles. If when you get the question and they say to differentiate from first principles, but you choose to do a different method of differentiation, as there are many, then you'll be wrong. The question says to differentiate from first principles, and you use one of the other forms of differentiation, then you would be wrong. Then you would be wrong. So you have to follow the first principles methodology. And the first principles methodology is differentiation using limits. Differentiation using limits. And it really isn't difficult. I trust that you will get this by the time we end this afternoon into evening.
I hope so too, sir.
All right, so let's go. So the formula is h, the limit as h tends to 0 of f of x plus h minus f of x all over h. The limit as h tends to 0 of f of x minus f of x plus h minus f of x over h. All right, let me just give you an explanation as to what is happening here. So f of x plus h minus f of x. Now, I am looking for an incremental change. So if you recognize, I am putting an h in the whole mix of things. So I'm saying f of x plus h. I'm looking at an increment, and that increment will tell me what change is taking place. And then no, when I have that change, then I'm going to subtract my f of x. Then I'm going to subtract my f of x. Then I'm going to subtract my f of x. I'm actually trying to type something here, but so I'm going to let f of x equal. I'm going to let f of x be equals to 2x squared minus 5x plus 3. So I'm letting f of x be equals to that. So they asked me to differentiate 2x squared minus 5x plus 3. But before I can differentiate it, I need to name my function. So I'm going to let f of x to be equals to 2x squared minus 5x plus 3. Now I want you to just picture this. Math is real life. So I'm going to use a real life explanation to see if I can get you to understand this. I want to see the incremental change. I want to see the incremental change. So I'm going to add a variable to it to see the change. Now I'm adding the variable to it. and the variable that I'm adding is h. Now when I add h to the stuff, what I'm going to have now is f of x plus h. That's the change. That's the small change that I'm adding. A small change. All right? So it becomes now f of x plus h. After I've added a small change to the stuff, I'm going to take out back when we add the original stuff and then just use a small change. So that's why I'm taking up at the f of x. Put it this way. 2 examples. You start in a business, you get $100,000 and say, you know what, I'm going to invest $100,000, you know. And you say, I have one little shop, I'm going to buy $100,000 worth of goods. And matter of fact, me lend you $100,000. I'm going to say to you, say, in a 3 months' time, I want about $100,000. I'm not going to charge you interest. I want about $100,000. 3 months' time, I say, Sir Sean, I can't do that. Because you know, say people come in your shop every day. And you take the $100,000 and you go stock up your shop with goods. And of course, you put your markup. And within 1 month, you pay me back my $100,000. So you're not indebted to me anymore. So the money that you have now is the profit of your business. And then as you get the profit, you turn it back over into the business and you make more profit. And you turn it back over and you make more profit. And that's how you run a business. That's exactly what is happening here. Other example I'll give you is you cooking a meal and you put your seasoning, you put your scallion and your thyme and your pimento and your this and your that. But when you put a share, share the food with the stuff.
No, it never come out, sir.
Right. So you have to take out some outside. That's exactly what it is that we're doing. So I'm explaining what you see in red there. I'm giving you some real life examples to explain what it is that you're seeing in red. So it is a limit as h tends to 0 of f of x plus h. The plus h that we're doing is that incremental change. Is the incremental change that we're talking about. All right? And then you're going to minus the original function. What is going to be left is going to be that incremental change. And when you find the limit of the incremental change, then that will give you your differentiation, which is really and truly your rate of change of y with respect to x.
You know what I'm
Go ahead.
understanding, sir, from what you said? Like you have the pot of rice and peas, you put in all the season to it tastes right, and then when it's done cook, before you share the food, you take out that, and what is left is a pot that tastes good without the seasoning.
Absolutely, absolutely.
Okay.
And when you go good hotel, and you drink and you eat them something, you're not supposed to even one speck of black
No
pepper
tree, no pimento seed, nothing
yeah,
like
not pimento, not
Yeah.
thyme. I mean, you may see the thyme leaf,
the
right?
fine
But
one,
the
not
stalk,
brown.
if you see the stalk in there, and you drink soup and the long scale and bunny from your chin go right down. Yeah, then there's something you have to see. You
I get
understand?
you, sir.
Right.
So
But
the age that you throw in there, which is like the seasoning that you go take out back afterwards.
true. So
Okay.
it's divided by age, because I'm
Uh-huh.
gonna take out back everything. Everything have to come back out. All right. So now that one of you understand this, what we're going to know is twerk it. Watch me. So anytime I see a x, I'm going to put a plus h because we're talking about that incremental change. So watch me. 2x squared, but sir, see the x squared, that means we're going to make it x plus h squared. See here? X plus h squared. So this is all up here. So where's my spotlight? Come on.
X plus h squared.
Right. So all of this is like my x. But every time I call a x, I have to put a plus h right there so. Right there so. Right? Because you are now investigating that incremental change. So now I'm going to put minus 5. See the minus 5 here? But see x here, I'm going to put x plus h. So why? Because we're investigating that small change. We're investigating that small change. So it becomes now 5x plus h. Okay, so I'm going to get you. Plus 3, but sir, we're not putting x plus h because there's no x right after the 3 here. All right? And then minus now f of x. You recognize that what is in the square parenthesis is exactly what the function is, f of x, because I'm subtracting it now from it. I'm subtracting it now from it. So I don't start working on limit set, you know. I'm not using a limit set, but I still have to write the limits here. So I'm simplifying this first before I even do the limits. Watch me now. So what I'm now doing now is doing this sort of expansion, what is x plus h all squares. Lord have mercy. There's something come up to haunt me again? Absolutely. Absolutely. So you have to know how to expand your bracket. So this x plus h is really x plus h times x plus h. Let me see if I can make this a little.
Sir, it no matter how you put
Say it again. Say it
No
again.
matter, it doesn't matter if you put x first or h first.
It doesn't matter, but it doesn't matter. It really doesn't matter. It doesn't. It doesn't matter. But I just normally write x plus h, right? Because it's after I call the x that I'm putting the increment. So it's not after I call the h I put in the increment. The small change is really my h. So I would write the x first. So after I write the x, then there comes a small change to the x, which is going to be the plus h. All right, so that's how I put x plus h. And I'm going to look into the textbooks. You see the plus h. Plus h is a subsidiary of the x. So it's after you write the x, then you have the plus h. So if you write the h first, it means that the horse come before, well, the egg come before the chicken, instead of chicken come before the egg, or whatever it is. Yeah, whichever one it is. But watch me now. This x plus h all squares, remember it is the same thing as x plus h times x plus h. Everybody remember that? X plus h all squares is the same thing as x plus
Yes,
h times
sir.
x plus. Okay, good. Now, so watch me now. So this is going to be x times x is x squares, x times h is xh, and h times x is the same xh, and xh plus xh is 2hx or 2xh, same difference.
Sir, usually you have the little line that go over the x, that go over to the x and go over to the h on that side, and then the h I go to the x and go to the h on that side when we're
Right.
working it out. So I'm
Right.
just imagining it, sir.
Absolutely. So that's exactly what it is. So want something move from here, so multiply by that, then the h multiplied by the h, and then the h multiplied by the x. Yeah. So I'm actually using one of the brackets to distribute over the other bracket. The truth of the matter is, and I really don't want to sound like a bad teacher. The truth of the matter is, this is not the class for me to teach you how to expand your parentheses. You are supposed to come to the class
Knowing how to do that, sir.
yeah, man. Right? So don't think that is a jump in the gun. I only put this x plus h times x plus h to jog your memory that we are multiplying those two brackets together to give me
Appreciate it,
x
sir.
squared plus 2hx, thank you, plus h squared, all right? Minus 5 times this x plus h is this x plus h here, and this plus 3 is the same plus 3 here, and all of this is the same as all of that here. So all I did in this line was just to do the expansion of the x plus h all squared to give me x squared plus 2hx plus h squared, all right? And then now I'm going to be distributing, because remember, BOMDA says I work my powers first, brackets first.
Yes, sir.
All right, so I have to do the brackets first, which is, and technically, x plus h all squares is really having two sets of brackets, x plus h times x plus h. So having done that, then now I can go ahead and distribute this 2 over everything. So 2 times x squared is 2x squared, 2 times 2hx is 4hx, and 2 times h squared is going to be 2h squared, minus 5 times x is minus 5x, and minus 5 times h is minus 5h, and this plus 3 is a standalone from the original question, and it stands alone here, it stands alone here, and it stands alone right here. But no, this negative sign is going to be used to distribute everything inside here. This negative 1 times the 2x squares, giving negative 2x squares. The negative 1 again times a negative 5x is going to give me a positive 5x.
Positive. Mhm.
All right, and this -1 times a
Negative
+3 give me a
3.
-3.
Mhm.
So now I have no brackets inside here. I'm going to see what it is and how best I can simplify. Now remember, I said to you that all of my f of x I am
Pause there,
taking.
sir. Pause there, sir. Pause there. That shit did I run too fast. You know, say you say you use on 1 there, so what? Me I look where the x did there where you use 1 from. Me the 3 plus 3 minus. Yeah.
Okay,
Right
so
there, sir.
yeah,
Yeah, which
this
they
is
get
just
that 1 right there, sir.
this is just okay. So it is um it is it is an imaginary one to sound. It's an imaginary one because the negative sign don't just stand by itself. So it's an imaginary one that is there. Can you see that? No?
Yeah.
All right. So is that -1 that is going to be multiplied by the positive 2x squares to give me negative 2x squares. And the -1 is also here. All right. So that's what I'm doing. So or if you want, you can just understand that I'm multiplying everything in this bracket here by a negative sign. And once I multiply everything by a negative sign, the sign is going to change. So if it is positive, it's going to become negative. And if it is negative, it's going to become positive. Watch it. This is a positive 2x squared. It now becomes a negative 2x squared. It's a negative 5x. It becomes a positive 5x. It's a positive 3. It now becomes a negative 3. Why, sir? Because you are multiplying through by a negative sign. And that's what the negative
Okay,
sign does.
yes, I understand, but I just show me the 1 to how you say. As long as there's a sign in a stand by itself, it have to be a 1 to stand beside it.
Very good. Yeah.
Okay.
All right, good. So now, also remember that I am subtracting out everything. Hold on there. All right, guys. So if you look carefully now, stop share. All right, if you look carefully here now, remember I did say to you that I am subtracting everything from it. Remember, think of it as if you are cooking and then you're removing your seasoning. I'm removing my seasoning. So look at what is going to happen. This 2x squares will cancel with this 2x squares. See here? The 2x squares them cancel out. And this negative 5x is going to cancel with this positive 5x. See them here? And of course, this positive 3 will now cancel the negative 3. Oh, sir. If when you're doing the question and anything from over here so is left in the question, something wrong. Every single thing over here is supposed to come up because remember, you put it in and then you take what it is that you would have put in and then what is left. What is left now is you look at profit is what you're going to use to run the business. Is what you're going to use to run a little business. All right. So now what I'm going to be left with is 4hx plus 2h squares minus 5h. See it down here, so this is what is left. Now I am going to be taking out this h. I'm gonna factor out because something here can be factored out. Each of these terms, each term has at least one h. So I can factor out that h. When I factor out the h, I'm going to be left with hx, 4x, sorry. When I factor out the h, I'm going to be left with 2h. When I factor out the h, I'm going to be left with negative 5. But this h down here, so now, cancels with this h up here. So now I don't have no fraction again working with it. I just have 4x plus 2h minus 5. See it right here, so? 4x plus 2h minus 5. Now, this is in its simplest form. Now I can take the limit. Now I am taking the limit. I'm taking the limit right here. Taking the limit right there. So as h tends to 0, stop. You notice I'm not doing the limit here just yet, I'm simplifying my function here. But you notice each of these places I have my limit h tends to 0, h tends to 0. If you don't have that limit h tends to 0, h tends to 0 every time, you're going to be losing mark.
Every time, sir?
Every single time you must have the limit h tends to 0, h tends to 0, h tends to 0 when you start a statement. You must have it.
Okay, sir.
All right. So now what it is that you're going to have is as h tends to 0, anywhere in the function you see h, you're going to put it equals to 0. As h tends to 0. So see here 2 times 0, right on here. So I'm going to left it 4x minus 5. So I put it 4x minus 5, and then I'm finding the limit. So remember now, the limit of a constant is a constant itself. The limit of a constant is a constant itself. So please be reminded that 4x minus 5 is a constant. Sir, no. The 4x as a variable, so how can it be a constant? It is a constant because I'm finding the limit as h tends to 0. Do you have any more h inside yourself?
No, sir.
Good. So all of this here is a constant. So that's why I put it back now as my answer. And when I differentiate the original function, this is what I would get as my answer. That's what I would get as my answer. And that ends that question. What I'm going to do for you, before I even take your questions, is to project the full question. Oh, Lord. Sorry, let me just reduce it one more time. I'm going to project the full question. And I'm going to give you a couple minutes to look at the question. All right, so I don't have to go.
Sir, I want to write it off. So I need to see the question, please.
I'll come in, honey. All right, can you see now?
Yes, thank you.
No problem.
I screenshot it, sir.
Huh?
I screenshot it.
Great. So what I want you to do now that you see the full question, I have given you now another question. So I'm going to give you some time. I am going to give you some time to go through what it is that I would have done here on this side. And then I'm giving you some time to look at the other question. I've given you another question, 4x squared plus 3x minus 1, and that you're going to be differentiating from first principles. I want you to use the steps that I would have over here to complete this question over here. I'm giving you 10 minutes to have that done. Thank you.
Okay, sir.
Right, I'm stepping away 1 minute, please. Ouch.
Jennar? Jennar?
Yes.
You are
Yes.
unmuted. You muted. You are unmuted.
Oh, I'm sorry.
All right, guys. Have we looked at the stuff? Have we attempted the stuff? The other question, the 4x² plus 3x minus 1?
Give me a little more time, please.
Okay, no problem. No, ma'am. I just wanted to find out where you are. No
Working
problem.
on it, sir, working on it.
I will just mute myself. Cool.
Sir, may I run a guess?
What is the guess?
May I have two things. 4x plus 3.
Okay. What's the other
I
thing?
may have 8x plus 3. I don't know how I get two of them. Yeah, I them may I run with. Yeah, guess.
Sir, I got 8x plus 3 as my
I
answer.
third that as well.
Yeah, man.
8x.
8x plus 3 is the correct answer.
Great.
All right,
I will- no.
hear the drama. Well, I know hear the drama before you talk. Because I tell you, I'll know I don't start look at. I'll know I don't start do nothing yet. I guess the answer.
Okay. Because you look, because you look at the answer for the first one to the question. All right. And this is what it is that I'm going to say to you now.
Yes, sir.
Yes, you can do that to double check that you are correct. But a question like this sometimes go for anywhere between 5 and 10 marks. If I don't see, no, I'm just saying to you, if you don't see all of them work out here,
come on, the work you out.
this alone I get the 1 mark for this. Okay, all right. So go on with the thing. So 8x plus 3 is the correct answer. Go on work. Soon come. Can I come back now?
Sir, I'm almost finished working it out.
All right. I'm going to give you 3 more minutes.
Oh,
3 more minutes. All right, cool.
thanks, sir.
Ready or not, here I come. All right, so let us look at what is happening here. So you have the um all right, so you have the question, and remember what the question is. 4x squared plus 3x minus 1, and we're doing it from first principles again. And the formula is the limit as h tends to 0 of f of x plus h minus f of x all over h. So anywhere you see that increment is when it is where it is that you're going to be working the stuff, and you're going to be adding your h. So every time you call a x, you are going to put a h beside it. Every time you call an x, you're going to put a h beside it. Every single time you call an x, you're going to have a h beside it. All right? So watch me now. It's going to be 4 times x plus h, because all of this portion now would have been your 4x plus 3x, x plus h minus 1. So that is the original question. And then now what we need to do is to subtract the f of x. The f of x is 4x squared plus 3x minus 1 all over h. And I'm recalling for you that x plus h all squares is the same thing as x plus h times x plus h. And how we get it? X times x is x squared. X times h is hx. H times x is another hx. And h times h is h squared. The x squares are standalones, I write it back. The h squares are standalones, I write it back. But hx plus hx is 2hx. So let me just change this and just put 2hx. All right, 2hx. So which is what it is that we have here, 2hx. All right. So that 2hx now, I'm going to substitute into this thing to get rid of my x plus h all squares to be x squared plus 2hx plus h squared. Remember, this course is not for me to teach you how to factorize or to expand. That's what you should have learned in the foundational courses, because you needed it also for pre-calculus, all right, or CSET math. But I'm only giving you a review right here in the recall. So now I'm going to say 4 times x squared is 4x squared. 4 times 2hx is going to be 8hx. 4 times h squared is 4h squared. 3 times x is 3x. 3 times h is 3h. The negative one stands alone, I put it back. And similarly, here to sound, I'm going to have this negative sign distributing over this bracket. So it means
Mr.
that
Shanda, stop a minute then, please. Go again, how you get that 2h right there?
The 2hx?
Yeah.
1hx plus 1hx is 2hx.
Okay.
You see it?
Yeah, I see it there, but I mean, I don't know how it. Okay.
Which two? This what you're
Yeah,
talking
that
about?
one. Yeah.
So when I expand x plus h all squares, this is what I get. And see this is what I tried to do right here for you. Not try, but this is what I did here for you. X squared plus hx plus hx. Hx plus hx is 2hx. I should.
I need to do nothing, sir. Make it time.
No. I just need to.
Well, explain why it is.
No, not explain. I may need to. Sorry. All right. Yeah. So this is it. This is it, Jenna. It is 1hx plus another hx will give me 2hx. So this is my 2hx right here. And that's all I got it. That's my 2hx right here. All right. And then no. And Jenna, are you seeing that?
Boy, Mr. Sean, yes, I see it when you write it right there, but from the top equation up here, I don't see where you got it from there.
Right here, so?
Yeah.
So that's what I'm saying. Is it this piece right here, so?
Yes.
Is what I'm expanding right here, so. So the x plus h all squares is what I have as the x plus h all squared here, and I'm working out right here the x plus h all squares.
Oh, okay. All
this
right.
is the piece that I'm working out now. And when I work out this piece here, I'm going to get this piece, x plus h all squares, is the same thing as x plus h times x plus h.
Right.
And then now, what I'm going to say now is this x, is where the spotlight is, that x times this x to give me x squared. That x times this h to give me hx.
Right.
This h times this x to give me another hx. And this h times this h to give me h squared.
All right, thanks. Yes.
And then now x squared is a standalone, says x squared here. But hx plus another hx is going to be 2hx.
Mm-hmm.
So that's why I have the 2HX right here. So
Okay.
and then
All
the
right,
H
thank-
square is a standalone. So you see it
Mhm.
now?
Yes, thanks.
Okay, no problem. And then no. So when I reach right here, what I'm going to be doing is to multiply everything in this bracket with the negative sign. So I'm multiplying everything in this bracket here with the negative sign. So this negative sign multiplied by everything right here, so it's going to give me a change in sign. So this -1, as I told to sound earlier, times the 4x squared is going to be a negative 4x squared. This -1 times the 3x is going to be a negative 3x. This -1 times a -1 is going to be a positive 1. What I try to do here is to color code it so you can see what is happening. So if you look at the greens will cancel, the ones will cancel. One is -1, one is +1, they will cancel. The pinks, -3x will cancel with a positive 3x. And the 4x squared cancels a 4x squared. Remember now, every single thing that you had inside of this bracket you're taking out. See here? That negative sign says that I'm taking it out. The negative sign says I am taking it out. So when I take it out, I'll have to find something up here to cancel out with it. And see here? This blue, this pink, this green. See here? Blue, pink, green. So I've canceled all of those, and whatsoever is left in black is what I'm going to rewrite. 8hx plus 4h squared plus 3h. And all of that is over h. Remember now, I must write my limit as h tends to 0, my limit as h tends to 0, my limit as h tends to 0 every single time. Because that's what I intend to do to calculate the limit of the function. I don't calculate the limit of the function if I can't remove it. If you don't have it, it makes your question incorrect. All right? So now, when I have this, I recognize that h, and all the time. It's not a matter of me recognizing every single time. You'll be able to factor out the h. So when I factor out the h, I'm going to have 8x that is left, 4h that is left, and 3 that is left. And then this h will be cancelled with this h. And when those h's cancel out, I'm going to have 8x plus 4h plus 3. And now it is that I'm going to apply the limit. And the limit says, as h tends to 0, so I'm going to substitute 0 into the function now where I see that. And I'm going to now left with 8x plus 3. So watch me. The question says to find the limit as h tends to 0 of 8x plus 3. It now becomes a constant. It now becomes a constant. Why is it a constant? Because there's no more h in it. So I'm just going to write back my 8x plus 3, and that is my answer. Others have seen the link. As I said before, there are many ways to do differentiation. There's only one way to do first principles. All right. I'm not going to ask you to do this example, this negative sign example, because the answer is already projected. You can, however, look at this projected answer to see if you agree with it. But your do know activity for me is going to be question number 4. Your question number 4. Anybody want to guess what question number 4 answer is going to be? Somebody guess and tell me what number 4 answer is going to be.
You mean just by looking at it, sir?
Just by looking at it, yeah. Let me see if
14x minus 3.
2.
Say it again, Emilio.
14x minus 3.
Okay, that will be correct. What will be the number 5 answer, Emilio?
4x plus 5.
Okay. All right. Here is trick question now, and that is correct.
No, don't ask about 6.
No. You can't tell me not to ask you because you have to answer them so. Right? No, me which one of me want to ask you the one here. What is the answer for number 6, Emilio? Bogey, it's talking on. That's not right. Aha. All right. But okay, so you see the gist with the other one. All right. All right,
Yes,
let's go. I'm going to give you a couple of minutes. Today's class, guys, is not for me to talk, it's for you to work it. And I'm going to be very disappointed if you guys just sit down and not doing what it is that I'm expecting you to do. I'm expecting you guys to be sitting down and working. All right, so I'm going to give you.
I worked this out already, no, sir. The one that we were working on, I worked it out. I got the same.
Yeah. The 8x plus 3 one.
I got the same as the 8x plus 3. I got that, sir.
Very good. So,
But looking at it from what Amelia has been doing, I think the first variable, I think I can call it variable, like in number 3, you say -3, you'd multiply that by 2, so it'd be -6. And where you have the variable again, the 2x, it would be -2. So that's what he's been doing with 4 and 5.
All right.
So it can't be done with 6.
It can actually, but it's just that you don't know the rules yet.
You put the 1 in front of it?
Maybe not. You don't know the rules yet. That's why number 6 is not so clear. So that's why I drop in that one, because I know some people would have seen that. But never mind. Continue working. I'm going to give you 10 minutes. And each time the time is going to go down. All right? The time is going to go down. So start working. I'm muting again.
Number 6, sir.
Number 6?
Which one,
no,
sir?
no. Number 6 is going to be. Number 6 is going to be. Sorry. Number 6 is going to be your homework. I really want 4 and 5 to be done
in this class time now.
So start working, please. On the mark, get it, go.
Okay. All right.
Sir. Sir. Sir.
Somebody confirm what number 4 was to be. What's the answer for number 4?
The answer for number 4 is 14x plus 3.
Plus 3, right? That's all. 14x plus 3.
Say it again. Say it again. X
Is
what?
it 14x plus 3?
14x minus 3.
Minus 3.
Yeah.
So, sir, let me get the plus 3 from.
Me
I'm
no
gonna
have
write this one again. Let me do wrong.
me no have a clue where you go wrong right there. So it's supposed to be 14x minus 3.
Sir, me have 14x plus 3.
I don't have a clue what you did. One. I don't have a clue. What
So
it-
I'm
Look
gonna
back at
write
it.
this so then if I write this one wrong.
Look. Look back at it, Titania, and see what. Just go through again and look to see where it is that your calculation. Just go through your calculation again.
Sir, I have two problems.
What two problems you have?
All right. The sign don't no matter, right, sir? Like how this the
Stop.
other one did have f of x and this have y. It no matter, right, sir?
No man, not a sign. Yeah, it's just like how you name Marie.
Yeah.
And me name Handsome. It's the same thing.
Any
Yeah.
side and you handsome same way.
Right. So y is equal to f of x, and f of x is equal to y. G of x is equal to y.
All right. One more thing, sir.
Uh-huh.
All right. All of this sign is we don't have any plus and minus, right, sir? When we have plus and minus, after a while something become plus, right, sir? So how is minus the for the 14x plus 3?
Supposed to be 14x minus 3.
Oh, it's still minus, sir, because it's minus. No, but I still minus would have bring plus. Yes, sir? I don't understand that part.
All right. Alright, so just allow me to stop share 1 minute. I hate when this second thing comes up and I can't seem to get it off otherwise. Alright, so let us have a conversation on that particular question. That particular question. Copy. Paste. All right, so it's now 7x squared minus 3x minus 6. 7x squared minus 3x. Oh, Lord. Minus 3x minus 6. 7x squared minus 3x minus 6. All right, look at my first line. My first line gives what I should have, where I'm making a substitution. We are making a substitution. So this number becomes 7x, that becomes minus 3 minus 6. That's minus 6, that's minus 3. And this is supposed to be 7.
Sorry if you don't have the minus one, yeah, all right? Same way.
Yeah, all right, man. You don't have to put the minus one there. You notice in the second line, I don't put the minus one. I only put it there because the son asked a question earlier. Yeah, man. Yeah, man. I don't have to put it there. So now I'm gonna get 7x squared plus 14x plus 7x minus 3x minus 3h minus 6 minus 7x plus 3x plus 6. I don't know if I'm right here. Yes, I am. And then now, what is going to happen is I'm going to have 7x, the 14x, the plus 7, minus 3, oh Lord, and then minus 3 again, and then minus 6, and then minus 7, and then a plus 3, and then a plus 6. Look at that. Is where it went wrong?
Yeah.
Great. Where did you go wrong?
1, 2, the third step. Instead of minus 3, I have plus 3.
Okay, all right. All right. Okay, okay, good. All right, so let me just finish off. And then I'm gonna end up now with 7, no, with 14x plus 7h minus 3h. Look at that so far, guys. My other piece of information is on the other page. Look at that before I move on, please.
So you're gonna cancel out the
I'm going to factor out the age now.
factor out the age from the 14 HX
Very good.
and the age from the 3.
Very good.
But sir,
Mhm.
the 7H right here. Oh no, that is when you're going to as H tend to 0. That is that time that one gonna come out, right, sir?
Very good.
Okay.
Very good.
So right beside the H, the plus 7H, you're gonna put 7 and the bracket and 0. Oh, see it here right here. So that is
Very good, Marie.
right. Sir, sir, after class done, me forgot this.
You know, I remember in another class you said that the fun is on.
Sir,
Oh, Jesus. But guess what? You can manage, you know. Others have done it and you can do it. Others have done it and you can do it. So no tell me so you can manage, you can manage.
Yes, sir, I can and I will.
And you must.
Right.
Sir,
Please, I'm
Sir?
hearing you. Go ahead.
sir,
I'm hearing you. Go ahead.
it's 7 o'clock already.
Rockstone. Jeez,
Yeah, I realize that you don't realize it.
Rockstone. I saw it's not
Yeah,
it's
we
not
get
7
carried away
o'clock.
when we get into math.
It
I
is
know.
7:01. Guys,
Yes,
I have to run.
Last
I have
night.
to run. Osh,
Yeah.
yeah, Osh. All right. So we
Sir,
will
let me
continue.
see about the homework. Let me see about the homework question.
Please remember to send this,
Excuse.
sir.
Yeah, man, I will do
Sir,
it. The
just
homework
send it
question
like
is
Yes, sir, thanks.
the homework question is X cube. I'll
Yes.
send it. Say it again, Marie.
Just send this, not with everything like you did what you sent yesterday. Just this 3 sheet that you worked today. You can't do
Absolutely. We'll do for you, hon.
all right, sir.
That's right, guys. Take care.
Thanks, sir.
No
Bye.
problem. Bye-bye. Cool.
All right, Chief.
Easy, bye. Class time is done.